Hello everyone, welcome to 14.1 day 1 notes. Here is your problem of the day. Let's get a color. So we are still practicing our distributive property. When you see parentheses, you need to know that we need to distribute or multiply the number that's on the outside to all the terms on the inside. So let's start with by splitting our problem down the middle. Then I'm going to take this 3. I'm going to multiply it to both terms on the inside. So I do 3 times x gets me 3x. Then I do 3 times 1 gets me 3. So it's going to be 3x plus 3 equals, I'm going to take this 4 and multiply it to x and multiply it to 3. 4 times x gets me 4x. And 4 times 3 gets me 12. Now my goal is to combine, well, not combine like terms. There's no like terms on either side. I have an x and a 12 and a 3x and a 3. Those don't mix because there's not variables on both sides. But we need to get the x's together and the constants together. So let's get rid of, let's get the x's together first. So let's make a 0 pair with the smaller x. Which x is smaller, 3x or 4x? Hopefully you said 3x. 3x is smaller, so let's make a 0 pair. That is a positive 3x, so I need a negative 3x. That gets rid of those. I'm going to subtract 3x on this side. Oh, look at that. What's 4 minus 3? Just x. That's what we want. So we got 3. X is by itself. Oh, but not completely by itself. We got to get rid of this 12 now. So how do I get rid of the 12? Yeah, let's make a 0 pair. So to make a 0 pair with that positive 12, I need a negative 12. That gets rid of this side. I'm going to subtract 12 from over here. Ooh, 3 minus 12. 3 minus 12. If you don't like looking at it like that, we can write it to the side. We got, 3 minus 12. So we can do keep, flip, change, keep, flip, change. Now I got 3 plus negative 12. Okay. Signs are different, so I can subtract them and then keep the sign of a larger number. So I'm going to do 12 minus 3. That's going to get me 9. And I'm going to keep the sign of a larger number, which is 12. So it's going to be a negative 9 equals x. Final answer. All right. Hopefully you're getting the hang of this. Now this is your turn to do this problem on Nearpod. Please complete this one on Nearpod. Check back here in a minute when you're done. All right. Hopefully you have good enough time to get that done. So first thing you should have done was split your problem down the middle, and then you are going to distribute these outside numbers, outside terms, to both terms on the inside. So you got 2x plus 2 equals 3x plus what? 3 times 2 is 6. Good job. All right, let's make a 0 pair with these smaller variables. That could be 2 or 3. Hopefully you said 2, so we're going to subtract 2x from both sides. That gets rid of the 2x's. I'm left with 2 equals 3 minus 2x is just x. That's what we like. We like that. But we still got that plus 6. We got to get rid of that plus 6. So we're going to subtract 6 from both sides. That gets rid of that. Subtract 6. Now I have 2 minus 6. So we have 2 minus 6. Keep, flip, change. 2 plus negative 6. Signs are different, so I'm going to subtract them. 6 minus 2 is 4. Keep the sign of the larger number, which is 6. So negative 4. So negative 4 equals x. Final answer. All right, hopefully you checked yourself along the way. This is the correct answer. Well done. If this is still rocky for you, we got more to come this week. Moving on, we are going to be constructing and identifying clusters and outliers. So we're going to be constructing and doing making graphs. So we're going back to graphs today. I know some of you it's not your favorite. We're going to plot the points, and then we're going to be identifying clusters and outliers, and then we're going to kind of interpret what the graph is telling us. So clusters is just a group of dots kind of all put together. An outlier is kind of like it's just like one, it's like the outcast. There's just like one out of nowhere that's not in the pack. So we got clusters, a whole bunch of them. Let's see if I can draw. So for example, cluster. Here's a cluster of dots. Yes, cluster. So let me show you a cluster with an outlier. So here's a cluster. And here's an outlier. The outlier is way out there. Okay, so outlier is way off to the side. A cluster is a little group of dots. All right, and then we're going to make an interpretation. Okay, here's my example. So Joyce is training for a 10K race. For some of her trainings, for some of her training runs, she records the distance she ran and how many minutes she ran. Make a scatter plot of Joyce's running data. Yikes. All right. So we got to just graph these. So look at the titles. So we got distance here, and we got, where's distance on the graph? Oh, distance is here. Okay. So when I look at the distance, I am going to go from left to right. I'm going to do the x-axis because that would also make sense because this should be our x and this should be our y. And is it? Let's see. Time is on the y-axis and distance is on the x-axis. So these are technically ordered pairs, folks. So we got, like, it can look like this. 4, 38. So some of you had the hang of this back in the day when we were plotting stuff on graphs, but look, they're just ordered pairs, so don't get too scared. All right, and so we're going to graph these. Not too much math today, okay? I guess I should just finish this. Okay, so we got 4, 38. So 4's distance, so that is on the x, so I have to go to 4. So let's see, let's do 4. So start at 0, 0. We go to 4, 1, not 1, 2, 3, 4. That's 2. We're not counting boxes. You got to look at what the scale says. So 4 is way over here. So this is going by halves. So we're going to jump all the way to 1, 2, 3, 4, and then up to 38. Now, do you see a 38 over here? I don't. So it looks like we're going to have some eyeballing to do. But let's figure out, let's see. I got 0, blank, 10. What could be halfway between 0 and 10? You got it. It is 5. So we got 5, 10. This is 15, 20, 25, 30, 35, 40, 45. So I made it past 38. It looks like I'm just going to have to kind of guess. So 38 is between 35 and 40. So I'm going to go to 4 and up to 35. Like 38 is a little more closer to 40. So I guess I'm going to put a dot like right there. Okay, so there's a dot. I'm not going to, I guess I could try to make it. All right, close enough. So that one. Now we have to do all of these. Yes, I know. Yes, you have to do them all. Don't complain. 2, 25. So we're going to 2. Oh, 25 is a nice one. 2 and 25, we got a nice one right there. 2 and 25. Okay, 1 and 7. Okay, 1 and, oh, we don't have a 7, so we're going to guess, kind of like in the middle. 1 and 7. All right, 2 and 16. 2 and 15. 16 is really close to 15, so let's kind of put it closer to 15 there. Okay, 3 and 26. 3 and 25, 26 is also really close. I'm going to put it right there. Okay, 5 and 55. 5 and 55, right on the crosshairs there. That's a nice one. 2 and 20. 2 and 20, also in a nice spot, right in the crosshairs. 4 and 45, so 4 And 45, also a nice one in the crosshairs right there. And last one, 3 and 31. 3 and 31. Okay. Now, our goal is to identify clusters and outliers. So, I wonder, can we see, let's like, do you see anything that's like kind of way out of the way? Things that are kind of not with the pack of dots? There's some stragglers there, aren't there? So I'm going to highlight the outliers in blue. I see this one being way out here, and then there's only one. This one has like 2, this one has 2, this one has 3. This is also one just has 1, so I think there could be 2 outliers. We got 2 outliers here. And I would say the cluster is in between here, so between 2, 3, and 4 miles. So I could say this could be the cluster. There might be a way, could say like maybe this is a cluster, this is a cluster, and this is a cluster. Maybe there's 3 clusters. But I would say the majority of her runs, and this is me, look, this is I'm interpreting right now. So now that we figured out where the outliers are and where the bulk, where all the clusters of her dots are, we make an interpretation, like an inference of what this graph is telling us. So if you look, our 2 outliers are when she ran only a mile and when she ran 5 miles. Those are the outliers. But I would say, here's my interpretation, the majority of her runs training for this 10K race are between 2 and 4 miles. Would you guys agree? She did 1, 2, 3, 4, 5, 6, 7 of her runs between 2 and 4 miles. She only did 1 5-miler and 1 1-miler. But she looks like she is getting better, or hopefully getting better with time. But as you notice, the longer the distance she takes, the longer it takes her to run it. Okay, that's about it. So you're graphing and identifying where the stragglers are and where the bulk of the dots are, and then kind of making an inference or interpretation of what you see on the graph. Be sure when you're making an interpretation of the graph, be sure to look at the time, like the axes and what their units are, because that will help you make a statement. Because you can look at the distance and see that she ran 2, 3, and 4 miles, and that's where most of the dots were. Or you could see that the farther she runs, the more time it takes, because you see the dots are kind of going up. So make sure these units of measurements will help you make interpretations. All right, let us know if you have any questions.